A big piece of Artemis III hardware heads for Florida, but the Artemis spacesuits might delay a moon landing into the 2030s. Meanwhile, NASA's Voyager 1 probe isn't doing so well, SpaceX sends off a drone ship, and Curiosity found some interesting stuff on Mars. As always, we've got all that and more coming up this week in Spaceflight. It was only 2 weeks ago that we saw the end of the Artemis II mission, and NASA is now preparing for Artemis III. But to properly do so, it needs to ensure that there's nothing major that needs to change between now and when that mission is supposed to launch. This week, the agency released a brief preliminary assessment of key items from Artemis II, and the conclusion is that, thankfully, not a lot needs to change. Following splashdown, the Artemis II Orion spacecraft was retrieved by the recovery operations team and secured inside the USS John P. Martha aircraft carrier. It was then unloaded in San Diego and has already begun the trip back to the Kennedy Space Center for examination, retrieval of components for reuse, and decontamination of hazardous materials like the cooling and propellant fluids. Thanks to the divers at the scene of the splashdown and aerial imagery of Orion as it descended under parachute, teams have already been able to perform early analysis of the heat shield, confirming that it performed as expected and that the modified re-entry worked to mitigate the avcoat spallation seen on Artemis I. More in-depth analysis will be performed this summer at NASA's Marshall Space Flight Center to help them better understand and characterize the condition of the heat shield and how it compares to pre-flight testing at NASA's Ames ArcJet facility. Engineers have also performed a preliminary analysis of the performance and accuracy of the SLS rocket during the launch of Artemis II, and have concluded that the rocket worked near perfectly and delivered Orion on target. What's even more important is that the Mobile Launcher 1 used on that launch of Artemis II is in way better condition this time around compared to how it was after Artemis I. The Mobile Launcher rolled back to NASA's Vehicle Assembly Building, and teams have already started the process of refurbishing it ahead of Artemis III. The SLS rocket for Artemis III is also slowly making its way to the Kennedy Space Center. Earlier this month, Northrop Grumman delivered the 2 aft segments for the solid rocket boosters that will power the mission. These aft segments will be outfitted with aft skirts and nozzle assemblies prior to stacking inside the VAB. And just this week, the upper 4/5 of the core stage for the 3rd SLS rocket were rolled out of the Michoud assembly facility in New Orleans and loaded onto NASA's Pegasus barge for transport to Florida. Once at KSC, the upper 4/5 will be joined with the core stage engine section, which was delivered back in 2022. Now, this is a departure from the way that prior core stages were built. Previously, the entire stage was assembled at Michoud and then transported in full to KSC. Starting with this core stage, the engine sections will be partially assembled in Michoud and will be completed at KSC. Final connection of the core stage tankage and its engine section will therefore occur on High Bay 2 inside of the VAB. Now, when it comes to Artemis III and beyond, the big question is, where are the landers? And we've talked about that one in depth in previous episodes. But there's another equally important question that's asked less often, and that's, where are the spacesuits? Well, this week, NASA's Office of Inspector General delivered a report trying to answer that question in particular. These suits are currently being developed by Axiom, and in fact, the company is working concurrently on both lunar suits as well as suits to replace the ones currently on board the International Space Station. But in summary, the main takeaway from this report was this chilling sentence saying, quote, "Based on our analysis, if Axiom experiences design and testing delays in line with the historical average for recent spaceflight programs, the Artemis and ISS demonstrations may not occur until 2031. Oof, that is not good, is it? Well, there is a catch. The analysis mentioned refers to a comparison of NASA's most recent programs related to human spaceflight, taking the average between when their contracts were awarded and when their first demonstration flight occurred. There are a few problems with that, though, like the fact that some of these programs were way too delayed, while others didn't take that long to implement. Some of the chosen dates are debatable, for example, by counting Exploration Flight Test 1 in December of 2014 as the first test flight of Orion, when it was mostly a boilerplate capsule at the time. Also, the fact that most, if not all of these programs encapsulate a much larger scope than the spacesuits that Axiom is developing. Now, this isn't to say that the analysis is entirely wrong, though. The report goes in depth into the myriad of things that have to be taken into account with both lunar suits and ISS suits. Both NASA and Axiom are working on tackling these challenges, for example, by pulling forward an early flight demonstration to be performed in 2027, either on Artemis III or on board the ISS. Axiom has also worked on moving to in-house production of critical components, such as batteries and valves, to mitigate supply chain risks. The company is also working with companies experienced in different fields necessary to develop the suit, such as Prada, Nokia, GU Energy Labs, and Oakley. While the report praises both NASA and Axiom for working towards final development and trying to push the program through implementation as soon as possible, it also criticizes NASA's decision to have spacesuits as a service rather than completing development in-house. Specifically, it states that, quote, NASA's requirements for xEVAs were overly burdensome for a firm fixed-price contract. The report also mentions Collins Aerospace, which was part of the original competition for the spacesuits and was contracted to develop the new ones for the ISS, but not the ones for the moon. This was because NASA thought that both ISS and lunar suits could be very similar to each other, so Collins or Axiom would just become the other's backup. However, Collins dropped out just a few years after getting the contract, leaving NASA with just Axiom as the sole contractor for both the lunar and ISS suits. The report criticizes NASA's decision to have dual-purpose spacesuits, stating that this likely dissuaded other companies from competing in the contract. Perhaps some preferred to only focus on either lunar or ISS suits, but not both environments. It then says, quote, ultimately, these factors resulted in NASA receiving only 2 bids for xEVAs, one from Collins, a contractor with extensive experience but poor management of its EMU spacesuit maintenance contract, and one from Axiom, a provider with no spacesuit development experience. Here's hoping that all the challenges can be solved in the next couple of years so that the Artemis astronauts will have a suit to wear on the lunar surface. 2 weeks ago on This Week in Spaceflight, we covered the proposed presidential budget request for fiscal year 2027, which of course has impacts on NASA and its future. That was, however, what's often called the skinny version of the budget. The full budget proposal was released this week and, well, it's not really that much fuller than the skinny version. NASA's overall funding is still cut by 23%, from $24.4 billion to $18.8 billion. That much hasn't changed in 2 weeks. But the line-by-line assessment that often appeared in previous budget proposals is no longer present for most of this one. For example, the NASA science portion of the budget that suffered the biggest cuts is being cut by 46%, from $7.25 billion to just under $3.9 billion. But which exactly are the missions being cut from the budget? Well, apart from some explicit mentions and certain budget lines being zeroed out for future years, the budget proposal doesn't mention the specific missions to be cut, nor does it show what NASA plans to spend in the current fiscal year for each of the missions in the NASA Science Department. These were items often present in past proposed budgets, and the only way to thoroughly understand what's being cut is to painstakingly compare this proposal to previous budgets and see which missions are no longer mentioned and where the money is going away. And that's about 50 missions that are either already underway, such as OSIRIS-REx, Juno, New Horizons, and the Chandra X-ray Observatory. Other missions that are in development, such as Da Vinci and Veritas, would be canceled as well, eliminating the only 2 proposed missions to Venus by NASA in decades. The budget proposes termination of several Earth science missions related to climate science, and also proposes a decrease of funding for other missions that avoided cancellation. That list includes missions like the Perseverance rover and the Hubble and James Webb Space Telescopes, as well as the development of the Habitable Worlds Observatory. Now, none of these proposed budget cuts to science are a surprise. As we mentioned 2 weeks ago when the skinny budget came out, the administration tried to do the same thing last year, and none of those successfully passed Congress. Still, this budget proposal shows the intentions of the current administration and what it wants for NASA's future. That said, there are some funding increases for certain aspects of NASA's science, but most of them relate to Artemis. Unsurprisingly, NASA's exploration programs are the only ones getting a funding boost under this proposed budget, some even copied over from last year's budget proposal. The budget also proposes to fund a new program called the Commercial Moon and Mars Infrastructure and Transportation, or COMMIT program, which would focus on developing a commercial transportation system from the Earth to deliver astronauts to the lunar landers. The agency is also sweeping the Commercial Lunar Payload Services Program, also known as CLPS, under this program. Under COMMIT, NASA would also have the Commercial Mars Payload Services Program, which is a sort of Martian CLPS. According to this budget proposal, the agency would fund a new, still unknown Mars science mission using this newly created program to be launched in 2030. Solicitation for this mission is expected to go out in October of this year for a total planned mission lifecycle cost of $220 million, a price tag that excludes launch costs. The budget proposal also revealed some information about what the agency expects to occur soon, as well as during fiscal year 2027. Some of these interesting snippets of information relate to the Artemis program. For example, it states that the critical design review for the Starship human landing system is expected in the third quarter of fiscal year 2026, which is between April and June of this year. So that means that we should be close to that key milestone in the lander's development. But it also states that Blue Origin is expected to produce a structural test article of its Blue Moon Mark II lander, as well as complete the lander's own critical design review during fiscal year 2027. The budget proposal funds a lunar surface propellant development project under its Office of Space Technology and phases out future development of plutonium-based radioisotope units for americium-based ones. This includes both heating units and thermoelectric generators. Also, remember that whole spacesuit story that we covered a few minutes ago? Well, aside from supporting the accelerated spacesuit testing in low Earth orbit, it also supports the development of a Mars portable life support system for future Mars spacesuits. I guess based on past experience, it's better to get going with that now than having to wait, huh? But as mentioned earlier, a lot of these proposals were already stopped by Congress last year. However, unlike last year, NASA now has an administrator, and Jared Isaacman has already had to face criticisms from Congress about this budget proposal. This past Wednesday, April 22nd, he appeared in front of the House Committee on Science, Space, and Technology. There, representatives from both sides of the aisle had lots to discuss and criticize about the budget.
Many of the proposed budget cuts were rejected by Congress previously, and I am confident that they're going to be rejected again.
These reductions do not exactly send a welcome home message to the Artemis II crew or to the NASA workforce.
Yet the administration is once again proposing transitioning away from SLS and Orion, even without alternative operational systems at this present time.
Sure, Mr. Chairman. First of all, I agree with you completely. If we're going to go through the trouble of building a moon base, we better be able to send astronauts there with great frequency on it. So we also put a demand signal out to industry for 2 different pathways so we can assure crewed access to the moon base that we are building. I have no doubt from my interactions with industry, the SLS players are all coming together, and that will likely be one of the pathways, almost assuredly Orion, as it is the only crewed vehicle that we have right now that can bring astronauts back from the moon.
Okay, I certainly hope you'll finish the second mobile launch platform as well that is nearing completion, and ensure that SLS has an upper stage to meet the 130-ton to orbit requirement directed by statute.
Now that's just the first of many hearings about NASA's budget process. Next week, Jared is also expected to appear in front of both the House and Senate Appropriations subcommittees on commerce, justice, science, and related agencies. It wouldn't be a huge surprise if there are similar criticisms and debates between legislators and the head of NASA, but one thing is for sure, you can bet that we'll cover those on next week's episode of This Week in Spaceflight. Now let's venture a bit farther into the solar system, because we got some exciting news from the Red Planet this week. NASA's Curiosity rover tried out a new experiment, and it found some new organic molecules. Okay, now there's a lot to unpack here, but we're going to start with the timeline of it all, because Curiosity didn't really do the experiment this week. It actually did it half a decade ago, but scientists needed a few years to verify the results. Back in October of 2020, Curiosity drilled into a rock in the Mount Sharp region and collected a sample. NASA named the sample Mary Anning III in honor of the 19th century paleontologist whose discoveries were often overlooked because she was a working class woman. Curiosity didn't ignore this sample though, and instead gave it special treatment in its onboard mini lab. It dropped some of the material into a cup with tetramethylammonium hydroxide, a strong solvent that broke it apart into larger molecules that Curiosity's instruments could analyze. This was the first time that such an experiment was conducted on another world, paving the way for future missions with similar capabilities, such as NASA's Dragonfly mission to Saturn's moon Titan and the European Rosalind Franklin Mars rover, which we'll talk about a bit more in just a minute. Scientists then used the same process on Earth to study a meteorite sample, which helped them to verify Curiosity's results. So what did they find? Well, the sample contained 21 organic molecules, and 7 of them had not previously been found on Mars. Now, organic in this case just means that the compound contains carbon. These kinds of molecules are essential to life, but they don't necessarily indicate life. That doesn't make them any less exciting, though. One of the molecules contained a ring of carbon and nitrogen atoms known as a nitrogen heterocycle, another first for Mars. This molecular structure is a precursor to the compounds that make up RNA and DNA. So even though all 21 molecules found by Curiosity could have been created without any life involved, the finding does add to the growing list of evidence that ancient Mars may have had the chemistry needed to support life. But Curiosity is just one of the robots exploring our planetary neighbor. The European Space Agency's Mars Express spacecraft has been orbiting Mars since late 2003, and it recently sent back an interesting image. The picture shows a stark color difference on the planet's surface caused by a blanket of ash, volcanic ash. Now that's not too surprising. After all, Mars is home to some of the largest volcanoes in the solar system. But there's something else going on. NASA's Viking orbiters pictured the same area back in 1976, but back then, the ash wasn't as widespread. And that's strange. Mars's giant volcanoes have been long dead, and we'd certainly have known if there was an eruption in the last 50 years. So what's going on? Well, it's possible that winds are spreading the ash around, covering a larger area with the dark dust. But it's also possible that the ash was there all along, just covered by the ochre-colored dust. In that case, the Martian winds would have worked the other way around, blowing the red stuff away to reveal the ash. Isn't it cool that we've been studying this planet for so long now that we can actually compare what it looks like today with how it looked half a century ago? Anyway, so I promised more about ESA's upcoming Rosalind Franklin rover. The project, which is part of ESA's ExoMars program, has a complicated history. Early on, NASA was involved with ExoMars, but then pulled out. After that, Russia joined the project and took on some of the tasks needed to help Rosalind Franklin get to Mars. They were meant to provide the launch and the lander and several other parts of the mission. But then Russia started a war in Ukraine, so ESA canceled the partnership. But the rover was already well on its way, and in recent years, ESA contracted out several mission parts to European companies, and even NASA jumped back into the project. NASA will now provide the landing engines, a nuclear radioisotope heater to protect the rover systems from the frigid Martian temperatures, and a mass spectrometer instrument. Oh, and they will also take care of the launch. They recently selected SpaceX to launch the rover atop Falcon Heavy. The launch date is set for no earlier than late 2028, and considering that Dragonfly is set to launch on Falcon Heavy that same year, the rocket will get to carry 2 nuclear payloads within just a few months. It certainly promises to be a big year for fans of big rockets. Now we'll take a look at some other stories across space, starting with Blue Origin's 3rd New Glenn launch, which featured the first reuse of a New Glenn first stage. The results? Well, it's a mixed bag. Or mostly negative actually, but the first stage isn't to blame. On April 19th, New Glenn lifted off from Launch Complex 36 in Florida following a slight delay. The first stage, named Never Tell Me the Odds, performed exactly as it was supposed to, showing that New Glenn first stages are fit for reflight. The same booster flew on New Glenn's second mission less than half a year ago, and just like on that mission, it went all the way up and down and landed softly on recovery ship Jacqueline. So far so good, but landing was only the secondary objective. So what about the flight's main purpose, delivering a Bluebird communication satellite to low Earth orbit for AST Space Mobile? Well, that is where New Glenn fell short. Despite the rocket's previous successes, the odds of successful orbit insertion weren't great on this flight. According to CEO Dave Limp, one of the BE-3U engines on the second stage underperformed and the rocket missed its target orbit. Not only did it deliver the satellite into a low orbit, but also in a different inclination than intended. AST Space Mobile later confirmed that the orbit was too low for the satellite to operate and that it would deorbit. That's a launch failure. Hopefully, Blue can fix the problems with its upper stage, as they also had one during testing a few weeks ago. But from what we can see, those problems didn't seem related, so there's certainly some stuff for them to figure out. SpaceX's drone ship Just Read the Instructions just saw its final landing. This week, a booster touched down on its deck for the 156th time, after which SpaceX announced that the barge would move on to new career opportunities. Instead of having its deck blasted by landing Falcons, the ship will be repurposed to move super heavy boosters from Starbase to the Cape. SpaceX wants to start launching Starship from Florida much sooner than it will have a Starship factory in the area, so it will have to ship the rockets in. That's where just read the instructions and the new transport barge, you'll thank me later, come in. But the drone ship retirement does raise some questions. Doesn't SpaceX need it to uphold its launch cadence at the Cape? Well, VP of Launch Kiko Donchev thinks that they should be fine between Florida's other ship, a shortfall of gravitas, and return to launch site landings. The latter don't happen too often, but they could always reduce the number of satellites on Starlink missions to make that possible. But that might not even be needed. They make one ship work out in California, so why not in Florida too? But what about Falcon Heavy? Does this mean that we'll never see dual drone ship landings? Well, Kiko teased that they may have some plans for that. But what? Landing 2 Falcons on one ship seems a little ambitious, or will Blue let them borrow Jacqueline for a few days? Probably not. There's one thing we know for sure. Whatever happens, you'll hear it in a future episode of This Week in Spaceflight. And if you don't want to miss it, you know what to do. Like and subscribe. It really helps. ESA's small spaceplane is getting real. This week, teams completed the first full-size Space Rider test model, which will perform landing tests. Space Rider is a small reusable spacecraft that will fly on Vega C, but its 4.6-meter-long re-entry module may not really look much like a spaceplane due to its lack of wings. Instead, it'll use its lifting body design to guide itself through re-entry, and then, after slowing itself down, it'll deploy a large parafoil and steer itself to land on a runway. While we've seen many similar concepts, none of them have actually made it to flight. ESA is now preparing for testing by dropping its newly completed test model. The vehicle was built in Romania, then shipped to Italy for final integration and testing. The parafoil was folded and integrated over 3 weeks, and it's truly massive, measuring 27 meters long and 10 meters wide, which will be enough to support the nearly 3 metric tons of Space Rider on the way down. The test vehicle is slated to perform a series of tests in Sardinia later this year, during which a helicopter will drop Space Rider from up to 3 kilometers. If all goes well, the first Space Rider is set to fly on Vega C in the first quarter of 2028. Now for some bad news from one of NASA's oldest active spacecraft. The agency had to shut off an instrument on Voyager 1. The spacecraft and its twin, Voyager 2, launched in 1977 and have since been traveling away from the Sun. Both are now traveling through interstellar space and unfortunately also nearing the end of their lives. The spacecraft are powered by radioisotope thermoelectric generators, which convert the heat of radioactive decay into electricity. The generators lose about 4 watts of power per year, which means that NASA has to be increasingly stringent with power budgets. The agency's been turning off more and more of the 10 instruments to preserve power. During a planned roll maneuver in February, Voyager 1's power levels dropped, and to prevent problems, engineers decided to turn off the low-energy charged particles experiment. The power saved would add about a year to the probe's expected lifespan. Voyager 1 now operates only 2 instruments, while its twin is down to 3. NASA hopes to be able to operate at least 1 science instrument on either probe into the 2030s. But they may also have a trick up their sleeve to give the spacecraft just a bit more life. Soon, NASA will test a procedure to turn off multiple spacecraft systems at once and replace them with low-power alternatives. If successful, this might even allow NASA to turn the low-energy charged particles experiment back on. Nothing's guaranteed, though. Either way, NASA is doing its very best to squeeze out every last bit of science that these aging spacecraft have left, so we'll hopefully see them chugging along for at least a few more years. From one of NASA's oldest explorers, we move on to a future explorer, as the agency has completed the Nancy Grace Roman Space Telescope. And they did it under budget and 8 months ahead of schedule. With the spacecraft fully assembled and tested, teams at NASA's Goddard Space Flight Center are now performing the final preparations to get the telescope ready for shipping to its launch site at the Kennedy Space Center. Once in space, Roman will use its wide field of view and its high-resolution sensors to create an incredibly detailed image of the sky in visible light and near-infrared. Scientists want to use this to help answer some of the greatest questions in astronomy, such as figuring out the nature of dark matter and dark energy. Roman will study how light bends throughout the universe as it follows the curves in space-time caused by massive objects such as stars and galaxies. This effect distorts the light like a lens, which is why it's called gravitational lensing. Scientists expect that this effect might help to unveil what's up with dark matter. But Roman will also study a smaller version of this effect called microlensing to detect exoplanets. Using this and other methods, the telescope is expected to discover thousands of new exoplanets. NASA now plans to launch Roman in early early September. It's contracted SpaceX to lift the telescope atop a Falcon Heavy, which will then deliver it to the Sun-Earth Lagrange Point 2, which is a pretty popular spot for telescopes, as both Euclid and the James Webb Space Telescope are already hanging out there. This is your weekly space traffic report provided by Next Spaceflight. Besides the New Glenn launch that we talked about earlier in the episode, this week saw several launches from around the world. SpaceX, of course, launched a few Falcon 9s, 2 of which lofted Starlink satellites, with both missions taking off from California's Vandenberg Space Force Base. The first of these also marked the 600th landing of a Falcon booster. The other Falcon 9 this week launched the GPS-3 SV-10 satellite into a medium Earth orbit. Now, this satellite has been pushed back and forth quite a bit. It was originally slated for Falcon 9, then moved to ULA's Vulcan to free up a Falcon 9 slot, only for it to then be moved back to SpaceX's Workhorse after Vulcan's latest SRB issue in February. Yeah, it was a bit of a confusing mess, but it ultimately ended up flying on Falcon 9 this week, lifting off from Cape Canaveral on Tuesday. The booster that launched it, B-1095, ended its 7th flight with a successful touchdown on the deck of SpaceX's drone ship. Just read the instructions. SpaceX then also promptly announced that it was the ship's 156th and final landing. But you already know that from a few minutes ago. Rocket Lab graced us with 2 launches this week. From Virginia's Wallops Flight Facility, the company launched a suborbital mission on Electron's HASTE variant. As we've become accustomed to with these missions, the payload and the customer weren't announced, but the mission was given a whimsical name: Bubbles. An orbital Electron lifted off from Rocket Lab's own launch complex in New Zealand for a Japanese rideshare mission named Kakushin Rising. JAXA provided 8 satellites, which Electron delivered into a sun-synchronous orbit, although one of the CubeSats intentionally split into 2 satellites after deployment, so I guess they actually launched 9 satellites. Up in space, the Progress MS-32 resupply craft departed the ISS. The capsule automatically undocked from the Zvezda module's aft port on April 20th at 22:08 UTC and re-entered several hours later. Later in the week, Russia launched an Angara 1.2 from Plesetsk, carrying a military satellite into a sun-synchronous orbit. And closing out the week, we had another mystery launch from China's Xichang Satellite Launch Center. They might release some details later, but the launch vehicle and payload weren't made public as of recording. Next week promises to be another busy week, and the star of the show will be a Falcon Heavy. Set to lift off no earlier than April 27th, SpaceX's 3-core Falcon will loft the Viasat-3 F3 communication satellite. We'll also get dual return-to-launch site landings, but one of them will use SpaceX's new landing zone 40, so it'll all look a bit different than what we're used to. Of course, the company also plans to launch more internet satellites as well, with 3 Starlink missions scheduled for the week, 2 from California and 1 from Florida. Amazon's LEO internet constellation will also see some expansion this week, with 2 launches currently scheduled on the same day, April 28th. From Florida, ULA's Atlas V will loft 29 LEO satellites, while an Ariane 6 will carry 32 from Europe's spaceport in French Guiana. Russia plans to launch another Progress resupply mission to the ISS, which will lift off from Baikonur on April 27th. It'll arrive at the orbital outpost 2 days later, taking the place of the vehicle that left last week. Now, there are a handful of additional launches set to launch no earlier than April. They don't have specific dates just yet, but there is a chance that one may be slotted in before the month is over. If you want to know when that happens, we recommend checking our Next Spaceflight app and website. It really is the best way to stay up to date with launches. And it's completely free. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.